All right, so Andrew is propelling himself off a diving board. You know his mass. And the diving board is flexed. This dashed line is where it wants to be. And since it's stressed, it's exerting a normal force of 1,200 newtons. So the first thing you do is draw all of the forces. So let's use our checklist. We must never forget this. Does he have weight? Yes, everything has weight. So there's the force of the weight, which is equal to mg, which we'll calculate in our miscellaneous column in a minute. Are there fans, people, or motors? No. Is he touching a surface? Absolutely. So he has a normal force of normal, that is 1,200 newtons. Is there friction? No. Is there tension? No, there's no ropes. Okay, so there's only two forces, the normal force and his weight. The next thing we need to do is calculate his acceleration. Okay, remember the acceleration is the connection between old school and new school. So I'm going to put all the columns here. We may or may not use all of them. We don't need a horizontal column because all of the forces are up and down. And in the miscellaneous column, that's where you calculate weight and friction. So his weight is 64 kilograms times 9.8, or 627.2 newtons. Okay, so acceleration could come from old school or new school. And the hints that it's old school are distance, time, velocity. We don't have any of that. So it's going to be new school. I'm going to use y just because his motion is up and down. Be careful though. Don't assume, oh, it's vertical, so the acceleration is negative 9.8. That's only true if he's in free fall, which means he's free from all the other forces, and he's not. He's got the force of the diving board. So, oh shoot, what am I thinking? Sorry, my bad. I don't know what I was thinking. I was thinking projectile motion. So I hope you caught that. Okay, vertically, that was old school. Vertically, the sum of the forces equals ma. And you want to put your plus and minus. We don't really need left and right plus and minus because there isn't anything going on left and right. So the normal force is up. The weight is pulling him down. He has inertia, so that's why that's there. It's going to resist the acceleration, and we're looking for A. So you were given the normal was 1,200 minus 627.2 equals, be careful, put the mass in there, and we're looking for A. Okay, these two, there's a decimal here, these two turn into 572.8 newtons is his net force, equals 64A. So his acceleration, look at that, it's positive because the diving board is flinging him upward. The net force is upward. So his acceleration is going to be basically 573 newtons divided by 64 kilograms, which is 8.95 meters per second squared. Okay, awesome. That is his acceleration. And again, it's positive because the diving board's force is bigger than his weight. Okay. If the diving board propels him upward for this amount of time, all right, ding, 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 time means old school. Using the acceleration found above, determine his speed at the end of the 0.6 seconds, and he begins at rest, like when the diving board is maximally flexed. So that is old school. Let's see what we know. Let's see. We don't really know X or X not. He begins at rest, and we're looking for the speed, and his acceleration is a positive 8.95, and the forces act for 0.6 seconds. So since we care about V final, let's use the velocity function. We started at rest. We gained speed at a rate of 8.95 meters per second times 0.6 seconds. So he propels himself up by pushing against the environment with a speed of 5.37 meters per second. Okay. Okay, then when he loses contact, he is now in free fall. Determine his max height. So again, max height sounds like it's about height, but it is initially about his vertical velocity being 0. And that velocity and height, that is all about old school. That is the biggest physics Sudoku I've ever seen. X naught is 0. X max is what we're looking for. V naught, it's a we need to restart the clock. He starts now with a speed of 5.37. Hopefully that makes sense to you. We're kind of like doing a whole new problem. Now his acceleration is negative 9.8. We don't really care what time this happens. But we do know that the speed is 0. Okay, because it's max height. So you could find the time that the speed is 0. Or we could say, you know what, I don't know and I don't care about time. I'm not going to make a graph, so I don't really need all that information. So I'm going to use don't know, don't care, but you could find the time. So his V final is 0. The speed that he left the diving board, which is his V naught in the second problem, he is in free fall now, and pretend like this is multiplied, x minus 0. Because I made the largest physics Sudoku in the world. Okay, what you get is minus 28.84 equals, watch your plus and minuses. It's 2 times negative 9.8, which is negative 19.6 times x minus 0, but that 0 goes away, so it's just times x. Okay, that's good that the minus signs are going to cancel. So his max height, oops, I should have said y because it's up and down. His max height is 1.47 meters. But if we were really like doing this out, I don't know, like for a real world engineering coaching problem, that we assumed x naught was, sorry, I'm having trouble changing the color. His x naught was above, this is where he had the speed of 5.37. So it doesn't count this distance here. That's when his speed was 5.37. So his max height is relative to where the diving board naturally is. Okay. Question 2. This is why I jumped on the force plate, so you could have some memory of seeing the pressure on the force plate. So she jumps on the force plate with a velocity. So that's going to go into our old school, and we have to put the minus sign ourselves. She comes to a complete stop. So V final is 0. After a certain amount of time, more physics Sudoku, and we have our mass. Okay. Question 1 says, or A, draw all of the forces. So the Earth is attracting her downward, and she is touching a surface. And so there's a normal force that is reacting to how much she's squishing it, so there is not a formula for that. Question B, determine her acceleration and explain why it's positive. Okay, so worst case scenario, you just drew a force diagram, you might say sigma F equals ma, and then you would realize that you don't know the normal or the acceleration. So that means don't worry about it. It means go to your old school. And hopefully you also had the hint that, you know, we had all this information that we know goes into the old school. Okay, I'm going to use y now because we're in the vertical. So y naught, we don't know what that is. V naught is negative 3.75. A is not negative 9.8. I can see where we did so much with projectiles. Please try to watch yourself that that's not, that you don't go on autopilot. That's actually what we're looking for. And V final is 0, and the time is 0.17. Okay, so the physics Sudoku tells us that, oh, let's make this black, that this row is complete. So that means use the velocity function. She came to rest. She was heading down at 3.75. So add 3.75 to both sides. And then divide both sides by 0.17. And you get an acceleration of, got to look at my answer key, 22.06. Okay, that should make sense that it's more than 9.8 because people come to rest really quickly, right? Their knees flex a little bit, and if you watch it in slow-mo, but it's much quicker than it took her to fall the distance where she was gaining that speed, right? So she's got to be stopping faster than pretty fast. So 22 is bigger than 9.8 because she's stopping so suddenly. Why is it positive? Because she is going down, and in order to bring her to rest, the acceleration and the velocity must have opposite signs, which means, or you can think about, she needs to be pushed upward in order to slow her downward. So the net force has to be upward. So the normal better be bigger than the weight. Okay, and then question C says find the force. So since we're looking for a force, that is a hint that we're going to use new school, sum of the forces equals MA. Go back to your force diagram. The force plate was pushing her up. Her weight was pulling her down, and she was accelerating. Okay, we're looking for the normal minus, oops, sorry. Trying to scroll okay, minus her weight, which I did not calculate in the miscellaneous. I'm going to do it right here. You decide what you like to do when you're solving problems. And the connection between old school and new school is the acceleration. So that goes in here. Okay, so then what you get is normal minus 559 newtons equals 1,257.42 newtons. So add 559 to both sides. Oh, sorry, I'm not being consistent. This is not, sorry. This should be force of the normal minus force of the weight. So the normal force is 1,816 newtons. Okay, awesome. Hope that went well. All right, so third question. I think it's the last one. Mallory's out on the golf course, and the normal is huge, right? Because it's in contact for so little time. You know the inertia of the golf ball, and you know that there you go, a teeny tiny amount of time. Okay, question A, find the horizontal acceleration. Okay, so we have a time, but we don't have enough other stuff, and we have this beautiful force diagram. This is, I know it looks like there's an angle, but I was just trying to give you some variety. So this is just being pushed horizontally, and so we're ignoring any friction on the golf tee. So this is just new school. That pressure, that normal force, is the only horizontal force, because we don't know friction yet, equals the mass times the acceleration. So divide both sides by 0.05. And that golf ball is accelerating at a huge number. I think I made these numbers up, so could be goofy. So 76,000 meters per second squared. I probably made that time way too short. That's huge. Okay, question B. Determine the speed of the golf ball after a certain amount of time. So that is old school. You do not have to draw the physics Sudoku if you don't need it to do the problems. You know, you have earned the right, if you have enough experience, to not do so. You decide what works for you. Okay, so teeny tiny amount of time. Huge acceleration. It doesn't even fit in the box. Started from rest at the tee, and this is what we're looking for. Okay, so a lot of velocity function in this worksheet. Okay, started from rest, chilling at the tee, equals 76,000 times a teeny minuscule amount of time, equals 33.44 meters per second. So that's about 75 miles an hour. So the result seems reasonable. Those numbers are a little bit goofy. Okay, that's the speed. And then C, so we want to know the distance the golf ball traveled, and that might seem kind of weird, but ask me in class if you want to see, or look it up yourself, like search golf ball slow-mo video. You can see that as rigid as you think a golf ball is, it will squish up as the golf club hits it, so that it'll deform, and then unsquish. So that's the distance it was squished. So I can't scroll up anymore. We want the distance that the golf ball traveled during this teeny tiny amount of time. And x naught is 0. V naught is 0. So we just have this massively huge acceleration times a teeny amount of time, all divided by 2. And when you run the math out, you get 0.00736 meters, which makes sense, right? Because it's the squish, it's how much it was squished. It's not how far it, went down the greenway. So 0.736 centimeters, if that helps you to think about it. All right, that is the worksheet. So hopefully it's making sense. You're feeling comfortable drawing the forces. You know when to use old school. I'm sorry, when to use old school, and how to use new school. That's probably maybe the hardest part right now. That's the new stuff. And just mixing and matching, like moving from one to another. That's the other skill, is knowing when to use what when. All right, hopefully that went well, and see you in class.